All right, welcome to topic number 16, inverse functions. Okay, so we talked about transformational functions, we talked about operations, how we can add, subtract, multiply two functions together. Then the previous topic, we mentioned how we can take one function and input into another function. Okay, that's called the composition of two functions. So here we're going to talk about something called the inverse functions. So remember, there are some graphs that are actually not a function. Okay, we normally just call them the relation. All right, so this thing called the inverse relation. Inverse relation means is the interchange between the x and the y coordinates or the x and or interchange between the x and y variables. So as you can see here, I have a parabola. We know a parabola opens up is a function. Okay, but the inverse relation of this parabola opens up is a parabola open to the right. So we know parabola open to the right is not a function. So what do we call that? We call that a relation. All right. So where did this parabola open to the right come from? It comes from the interchange between all the x and y variables from the parabola opens up. If you interchange every single coordinates on the x and y, then you end up with the inverse relation. So for example, if you look, if we approximate what this point is down here, the very bottom of this U, we can say maybe this is like 1, 2, right? Maybe like a 3, -6. But if I interchange between these two coordinates, then I end up with -6, 3. That would be this part. That would be the very left of this parabola open to the right. Okay, so inverse relation simply implies all the interchange between the x and y coordinates, and or it can be the interchange between all the x and y variables. All right. So here I have a relation. Okay. Did the x value repeat it? No. So we know this relation, these 1, 2, 3, 4, 5 points together is a function. So what is its inverse relation? Its inverse relation we will denote as z -1. It's not z to the -1 power. It's called z inverse. The -1 is referring to inverse. The inverse of z will simply be the interchange between all the x and y coordinates. -3 comma 3 becomes 3 comma -3. -2 -1 becomes -1 -2. -4 -4 become -4 4. So all the interchange between the x and y coordinates, all right, become will be its inverse. All right. Find the domain and write it as a set notation using the brace. All right. So for my regular z, the domain, well, let me put it this way. The domain was I'm just gonna write it in just like this: x2, 4, -3, -2, 4. Oops, not the z. Here's a d. All right, for the inverse, the domain is now -3, 2, 3, -1, -4. No repeating x, right? So that inverse is also a function. All right, find the range. So the range for the regular relation, all the y values, 2, 4, -3. Oops, go up a little bit. -3, 2, 3, -1, -4. Using brace, it's just points. These are just points, not the actual, none of the points being connected. For the inverse, the range will just be 2, 4, -3, -2, and 4. Okay, that's all it is. All right, let's take a look at this concept. A function is 1 to 1. A function is said to be 1 to 1 if every pair of distinct element of x1 and x2. So what that means is you have two x values that are different in the domain. All right, x values are in the domain. Then f of -1 does not equal to f of -2. So what that means is if you have two different x values, maybe like 1 and 2, if you substitute these two x value back into the same function, f of x1 means the y value. The y value cannot equal to each other. All right. This means that every element of the range paired with exactly one element of f. Okay. Every element of the range, okay, pair exactly with one element in the domain with the x value. So very similar to our vertical line test. To be a function, every x can only correspond to exactly one y value. All right. So I use the example of boys and girls. Okay. It just turns out we cannot have the same boy with a different girl. You cannot have the same x go to different y values. In that case, it is not a function. Here is actually backwards, okay? Because the definition itself only says, okay, every x, every distinct x, every different x can only go to, every x, every different x, substitute back into the function, the y value cannot equal. So that means what happens if they are equal? What happens if I have two different x value, substitute into the function, and the y value comes out exactly the same? So if you have a 1, 3 and a 2, 3, 1, 3 and a 2, 3, if you plot them on the graph, you actually end up with a horizontal line. So if they are equal, then there's not 1 to 1 function. To be a 1 to 1 function, every distinct x can only what? Their y value back in, coming from the function got to be different. If they are the same, then you're not a 1 to 1 function. So that's why this thing called the horizontal line test is being used. Horizontal line test is used to determine if the graph of a function is a 1 to 1. If the horizontal line crosses the graph more than one time, then that function is not a 1 to 1 function. Okay. So just like this parabola I drew here, this parabola is a function by vertical line test. But if I use a horizontal line test, that tells you that parabola is actually not a 1 to 1 function. It is a function, it's just not a 1 to 1 function. And you might say, well, Mr. Chan, what's the big deal about it? Okay. It turns out you can actually find the inverse. If a function is a 1 to 1 function, then you can actually find its inverse. If a function f is 1 to 1, then you can actually find its inverse function. If it is not a 1 to 1 function, then you cannot find its inverse function. Not 1 to 1 function means can't find its inverse function. So what do you get? You cannot find its inverse function. So that means you get yourself what? What you so called an inverse relation. That's why this word is right here. Because the inverse of a parabola is not a function. So we cannot call them the inverse function. We have to call them its inverse relation. All right, that's what it means. Even though the function is a function, but it's not a one-to-one function. If it's not a one-to-one function, you cannot find its inverse function. Its inverse is not a function. So we just denote them as a relation. All right, so graph the following function in a graphing calculator and determine if the function are one-to-one or not. So I'm not asking you to solve them. I'm not asking you to solve them right now. I just want to simply you graph them. But this is not graphable. I got to put this in the graphing calc. In order to put this in the graphing calc, I got to solve for y. So these are the same example I used before, okay, when we solve for y. For this relation to be a function or not a function, we got to solve for y. So I'm gonna square both sides first. Get rid of, because my square root is already isolated. So that gave me 3 minus y squared. All right, since the y I'm solving for is negative, I am going to move it to the other side and bring the x squared back. So that will be positive y squared equal to negative x plus 3. Negative x squared, excuse me, plus 3. All right, to get y by itself, now I will take a square root on both sides. And remember, when we take a square root on both sides, my answer should always be positive and negative. So if you can recall, we had to put two functions into the graphing calculator, the positive square root and the negative square roots. And you can probably recall what this thing gonna look like. Negative square roots of negative x squared plus 3. This is gonna look like a circle graph. So this circle graph, does it pass the horizontal line test? No, it does not. Okay, so this one is not one-to-one. All right, this one here, set the x as over 1, solving for y. Cross product, x times those two terms is x times 5y minus 1. Set equal to 7y plus 3 times 1 is still 7y plus 3. So I'm solving for y, so I need to do distribution here, bring my y to the outside the parenthesis. 5xy minus x equal to 7y plus 3. All right. I want my y to be on the same side of the equal sign. So I'm going to move this 7y to the left. The negative x go to the right. So I get 5xy, positive 7y come over becomes negative. All right. 3 still 3. Negative x come over become positive. Since my variable y is trapped between two terms, I can factor out my y. So that leaves me with 5x minus 7 equal to 3 plus x. And now I can just divide both sides by 5x minus 7. So my y is equal to 3x, 3 plus x over 5x minus 7. So this is a rational function. All right, 3 plus x. So I'm going to put that in the parenthesis. 3 plus x divided by 5x minus 7. All right, gotta be very careful now. Don't let this kind of trick you. Remember, this thing look flat, right? This rational function, when it goes this way, it look kind of flat. So a lot of students think, okay, that's a horizontal line. No, 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 no. This part is actually coming towards the x-axis, okay? But it's getting closer and closer and closer. It does not mean it's a flat line. It just hover right above the x-axis. So if you look at the x value as it keep on going to the right, As the x value keep on going to the right, look at the y value. The y value is getting smaller and smaller and smaller. It's never actually exactly the same number. So it's not the constant part of a function. So we mentioned the constant part of the function means a horizontal line. Horizontal line, all the y values are the same. See, these y values are not the same. Okay, so don't let the graph trick you. These it might look like a horizontal, but it's not. The y value is getting smaller and smaller and smaller towards the x-axis. So does this pass a horizontal line test? Yes, it does. Okay, because if you draw a horizontal line, it only touches one time. So yes, it is a one-to-one function. All right. I don't even have to graph this one. You should know yes or no. Absolute value function, the V, right? How do I know this V open up? How do I know this V opens upward? Normally a V is open upward, right? This one does not have a reflection about the x-axis. Reflection about the x-axis will actually make the V go down. This one does not have a reflection about the x-axis because right in front of this x right here, inside the absolute value, there's no negative sign there. So I know this V opens up. So just like parabola, draw a horizontal line across it, not a one-to-one. It touches more than one time. All right. I'm not quite sure what this thing is, but I do want to graph it. Fourth power. This is actually considered as a polynomial function. We will begin to talk about that at a later topic. -3 plus x, whole thing to the fourth power plus 1. It looked like a U, but it's not a parabola. Okay, so it looked like a U. So if you draw a horizontal line across it, there is not a one-to-one function. So I'm gonna do like this. Okay. Let's see right here. See that right there? When x equal to 2, y is 2. When x equal to 4, y is 2. So you see you got the same y value. So that tell you that this is not a one-to-one. It's a U looking thing, but it's not a parabola. So if a function is one-to-one, then a formula for its inverse can be found using these three steps. Okay. So the inverse function of f is denoted as f inverse, like I wrote earlier with the z. Inverse function will be denoted as f inverse, not f to the first power. Okay, just called f inverse. So if you have a function g, its inverse will be g inverse. Okay, that's how we write the notation. So if a function f is a one-to-one, then what we can do to find its inverse function is replace f of x with a y first. Interchange between the x and y variable. This is the key right here. To find its inverse, whether it's a function or a relation, you got to interchange between the x and y variable or the coordinates. That's how you find its inverse. All right. Once you interchange between the x and y, you're gonna solve for y. Once you solve for y, then if you are y equal, then you are a function. So now you can replace the y with f inverse of x. Okay. So there are four things we're gonna do. I'm gonna divide them up into steps. Okay. So let's practice a little bit, then we'll do a bigger one. All right. Step number one is changing f of x into y equal. Step number two, interchange between the x and y variable. So this y is not going to be x. This x is now become a y. Step number three, solve for y. So now this becomes my variable term. I'm going to move it to the other side, okay? Bring the x back. So that should be positive y to the third equals Positive x come over, become negative x, right? I'm gonna put it in front of the -4. To solve for y, I will need to take a cube root on both sides, not one term at a time. Okay, when we take a square root on both sides, you're not doing one term at a time, you're doing the entire side. So both term on the right side will be underneath the same cube root. So my y is equal to cube root of -x minus 4. All right, step number 4, changing y back into f inverse. Okay, so I'm gonna go to the calculator. I'm gonna type in the original function, -4 minus x to the third. All right, I'm gonna graph it. That's original function, cubic function. All right, so imagine every single x and y coordinates interchanged the numbers. Then you come up with the x, then you come up with its inverse. So this is a one-to-one function, so that's why we can formulate. We follow the 4 step and find its inverse function. So I'm gonna show you. Purposely, I'm gonna type in cube root, math number 4, cube root of -x minus 4. Okay. Now this line horizontally is its inverse. Okay. So when this line, when this thing right here on the side of the calculator disappears, that means the function is already graphed. All right. Now I'm gonna go back to y equal, and I'm gonna clear out the second line. All right. So this is the original one, right? Another way to graph is inverse. I think if I remember the steps correctly, you don't have to do this. I just want to show it to you, okay? So you can see the same graph. Let's see if I remember it. All right, you go to draw, and you go to draw inverse. All right, draw inverse. Draw inverse of y equal. All right. So I think it's under bars, y bars, number 1 function. I'm gonna choose y1. Draw inverse of y1 and graph. Oh Lord, it didn't graph. Enter. There you go. That's the same graph as I drew earlier. All right. So that's how you actually draw the inverse. Because I can actually show you an x square. Remember now, parabola is a function, but it's not a one-to-one function. So if it is not a one-to-one function, then you cannot find its inverse function where you can actually put it in the graphing calculator. So how do you graph the inverse of a function that is not one-to-one? You just kind of follow the same step. Draw number 8, draw inverse, go to vars, y vars, and choose function and choose y1 where you put your graph is. Then you will draw it for you. There you go. Parabola open to the right. All right. Do you remember what cubic function looks like? Cubic function, what I just drew is a cubic function. All right. Cubic function looks something like this. But don't let it fool you now. This is not a horizontal line. This is not a constant part of a function. Okay. The y value just rises very slowly. Okay. Go down very slowly. But it's not a horizontal. There's no constant part of this function. So it is a one-to-one. A cubic function is one-to-one. So I can find its inverse. So step number 1, replace f of x with y. All right, interchange between the x and y variables. Step number 2. Step number 3, solve for y. I'm gonna get rid of the cube root, but I need to move the 3 over first. So that'll be x minus 3 equals cube root of y plus 5. So to get rid of the cube root, I'll just cube both sides. All right, that cancels out. So my y plus 5 is equal to x minus 3 cubed, whole thing cubed. You're not gonna multiply this out, okay? Because just to get y by itself, all you have to do is move the positive 5 over. So that'll be x minus 3 whole thing cubed as one term. Positive 5 come over, become negative. All right, now I replace y with f inverse of x. So this is my cube function. So what are we saying with this 2 example? We are saying the inverse function of cubic function is cube root function. And we prove it right here. If you started with a cube root function, its inverse is a cubic function. All right. Rational functions normally are inverse functions. You can graph it. Okay. You can actually graph it and see, but earlier we already kind of solved it and saw that inverse. Okay. So we saw that rational function is a one-to-one function. So if it's a one-to-one function, we can actually find its inverse. Remember, rational function looks something like this. So it is a one-to-one. All right, so step number 1, changing f of x to y equal. So number 2, interchange between the x and the y. So as you can quickly see, this example now look very similar to earlier what the example I just showed you. That's the reason why I kind of went over it again. So we've done something like this before. So to solve for y, we will use cross product. The x means x over 1. So x times y plus 3. So they equal to negative y minus 4 times 1 is negative y minus 4. Distribute. That should give me xy plus 3x equals negative y minus 4. Give myself a little more space. All right, so variable y need to be together. So I'm gonna move this y over, move the positive 3x to the right side. So I should get xy, still xy, negative y come over, become positive. All right, positive 3x come over, become negative 3x, negative 4 still there. So here, I need to factor out the y. But once I factor out the greatest common factor y, what should be left for the first term is x. What should be left right here? If I factor the y, what should be left? Not a 0, but a positive 1. Because y going to positive y is positive 1 time. All right, so divide both sides by x plus 1. Negative 3x minus 4 over x plus 1 will be the inverse function. All right. Square root function, we know it looks something like this. All right, even though it might be reflection about the y-axis, it's still going to be one-to-one function because there's no constant part of that function. All right, so let's find its inverse. This is a little bit tricky. All right, y equals, right? Replace f of x with y. All right, interchanging between the variable x and y. So that will be x equal to square root of negative y, right? Negative y now, plus 3 minus 2. Solving for y, I'm going to move the negative 2 over so I can isolate the square root term. All right, I'm going to square the entire side, okay? entire side. So square and square will cancel out. Negative y plus 3 is equal to x plus 3 whole thing squared. All right, I'm going to move the negative y over, become positive. I'm going to move this square term to the right. That'll be negative x plus 3 whole thing squared plus 3. All right, so now changing it back to inverse. Negative x plus 3 squared plus 3. All right, so that should be my inverse. Okay, I'm going to grab this function for you. Square root of negative x plus 3, close parenthesis, minus 2. All right, that's what it look like. I'm gonna go back here to my home screen. I already got my draw inverse y1. So I'm gonna just say second entry. I'm gonna cheat so I don't have to go through that steps. I'm gonna press enter to graph it. That is the inverse. That is its inverse graph. So you gotta be very careful. Interchange between the x and the y, right? Now when I square both sides, all right, now when I square both sides and then solve for y look like this. However, if I actually put this into the graphing calculator, this will actually display a parabola. But that parabola is actually not complete. Okay, this is not an entire U. All right, this parabola, if I will graph it, literally put this function in the graphing calculator, it will give me a whole entire U. But as you can see, it's actually not the entire thing because there are actually restrictions right here in place where your parabola, you actually cannot draw the entire parabola. Okay, so inverse of a square root function is not really the entire parabola. It's actually part of that parabola. So that's why I'm going to show you this example. I'm going to looking at it from a different perspective. I'm actually going to give you a function that is a parabola, but giving you a condition. X got to be greater than or equal to 4. X got to be greater than or equal to 4. So that means we can only thinking about X value to the right side of 4. Anything else, we cannot count them. It's not part of my condition, so it's not part of my graph. So I'm just gonna quickly draw this for you, and as you see, okay, here's a U, but I can only look at from 4 to the right. So that means this U, I can only look at it from positive 4 to the right. I know this point is 4, negative 3 right now because there's something else I want to show you in another topic. So this is only half of a parabola. Half a parabola is a one-to-one function. So I actually have its inverse. So I'm actually gonna find its inverse function using half a parabola. And of course, you kind of already knew this half a parabola is probably gonna end up with some sort of square root function, which is true. All right, replace f of x with y and write the resulting equation. So I'm gonna replace f of x with y. And I'm gonna purposely write this because I do want you to write them. The condition, write the condition. The condition is the key. Why this thing gonna become an inverse function. Step number 2, interchange between the x and y variable. Write the resulting equation and its constraint. So think about it, man. I just interchanged between the x and the y variable. So that means this x, the original condition was x greater than or equal to 4. Now interchange between the variable. Now this got to say y is greater than equal to 4. So my inverse function, okay, its condition what the variable also got to be inverse, got to be interchanged. All right, solving for y. So I'm gonna move the -3 over, and so I can isolate the square term. So I can take a square root on both sides. This problem give a lot of student trouble because it's conditions. Square and square root cancels out. This is y minus 4 equals. Normally, when we take a square root on both sides, the answer is always positive and negative. Square root of x plus 3. To get y by itself, I move the 4 over. So that will be 4. I'm going to put the 4 in the front, okay? That will be 4 plus or minus square root of x plus 3. My condition, y got to be greater than equal to 4. Y got to be greater than equal to 4. All right. Now, 5 and 6 is about finding points, okay? So I'm going to do this on the side to make it to show you. If the y value got to be bigger than equal to 4, then what x values are allowed? Okay. So I'm going to purposely pick 0. If x is equal to 0, substitute into the function. 4 plus square root of 0 plus 3. 4 minus square root of 0 plus 3. This is going to become 4 plus square root of 3. The other one is 4 minus square root of 3. Remember, the condition says y value got to be bigger than or equal to 4. So 4 plus square roots of 3 is that. 4 minus square root of 3 is that. Which one of these two y values is bigger than 4? The first one. So that first one tells you that it has to be a plus. You actually cannot use both plus and minus because a minus is gonna give you y value less than 4. So your inverse function is actually 4 plus square root of x plus 3, not 4 minus. That is the trick. That's the tricky part. So my inverse function is 4 plus square root of x plus 3. Okay. All right, looking back at the function f of x, find 2 points that satisfy the constraints. All right, so if I were you, I will graph this along with this constraint, and I will actually go use a calculator to give me 2 points. All right, I already graphed it, right? Remember, I can only pick x value bigger than or equal to 4. So the first one I'm going to pick is 4, -3. I already knew the 4, -3 is a point for that half a parabola. All right, I'm gonna go back. So this is a function f, right? Original function. I'm gonna just pick, maybe like a 6, 1. All right, looking back on the function f inverse, find 2 points. So rather than guessing what number for x substitute here plus 3, take a square root will come out to be an integer. Remember, inverse function is about interchange between the x and y variable. So once you already got the points for f of x for its inverse, all you have to do is just interchange the x and y coordinates. Those are the points. It's going to be on the inverse. Right? That's the whole point of it, is the interchange between the x and y variable or coordinates. So now we're going to graph it. We're going to plot these 2 points and then kind of draw our original function f, that half a parabola thing. I kind of already drew it, so I kind of know what it looked like. So 4, -3. 1, 2, 6, 1. All right, I know it's a half a parabola, right? Okay, make a little curve, you know what I'm saying? Not a straight line. All right, so that's my function f. My f inverse, -3, 4. -3, 4. Right here. 1, 6. 0.16 right here. So which way does it go? It's not a straight line. It's not a straight line because this is a what? A radical function, right? This is a radical function. Radical square root function normally look like this. So I know this function, it must go this direction. Something like that. I'm sketching it. If you don't believe me, right? I got this, well, see, I can't even draw it. I cannot actually draw its inverse because the condition does not, the condition is x got to be greater than or equal to 4. So in the calculator, I cannot take off this. I cannot take off this half of it. But what I can do is, if I know I'm only looking at half of it, I can still draw a parabola open to the right, and I'm only going to pick half of it. I must be picking the top ones because I kind of know what it looked like. So we go to second draw. From here, second draw number 8. Go to vars, y vars, choose number 1 function and choose number 1. See right here, this and up is what I needed, not the bottom part. All right, so if you don't mind, I'm gonna write some points here, okay? This point in the very right here got to be 4, -3. So the interchange between these 2 points, that means this point right here is -3, 4. So it's very important that you actually find the very bottom of that parabola. And I knew that because of the shift. I kind of knew that because of shift. Okay. This number tells me I shift to the right. That K tells me I shift down 3. So I went to the right 3, went to the right 4, down 3. So I know my bottom of the U has shifted. So I did that from the transformation. But there's actually another way, another thing I'm going to show you. All right, find the domain for the inverse. Okay, the inverse was a domain. This thing is going to the right, so from -3 to infinity. All right, -3 is on the line, so I got to use the brackets. All right, inverse, the range, the y value from here, keep on going up, so I got to be from 4 to infinity. Okay. All right, so the homework questions, real quick. Inverse relation is interchange between x and y coordinates and interchange between the x and y variables. All right. If you don't mind, solve for y equal, graph it, and tell me whether that function is a 1-to-1 or not. And the third question is going to be on the handwritten portion, and exactly what I just went over, except the condition is different. The condition now is x is less than or equal to -3. Okay, so that means here I have a u, right? The very bottom got to be -3, 4. Right? The transformation tells me that this has shifted to the left 3 and up 4. But the condition tells me I need to look at all the x value to the left of -3. So the right side of the parabola, you don't need. It's the left side you need. All right, this is a half a u, half a u. Now follow the steps, just like I show you. Okay, write the constraints. The constraints here must be turned into y is less than or equal to 3, because the constraints will tell you that when you get to step number 3, are you gonna have, like, is it gonna be a positive? Yeah, are you gonna pick the +1 or the -1, the square root? Earlier, I picked the +1 because I actually had to try. I picked the +1 because I had to try to put numbers in there, okay, to show that, hey, for the y value to be bigger than 4, only the +1 works. That's why I erased the -1. Okay, so make sure for number 3 you don't have a plus or minus here. I actually count that wrong. You need to determine based on the constraint which one you need, because when you take a square root, the answer is positive, negative. But you need to tell me by trying some point. You need to tell me it's a +1 you need or the -1 you need. Okay. All right, that will conclude this video. Thank you for watching.